output power. The output power based on wind turbine. Okay? So finally we got the power of the wind turbine is E 1/2 rho A V 2. So rho is the air density. A is the area, sweep area, which means if you have a turbine, and this A, this area. And velocity. Which is air velocity. Okay. And then there's a base load. Base load. Okay. Or base limited, which is the cylindrical. So this is based on the theoretically, it is impossible to over 59%. Okay, and the best design is also only 35 to 45. But if you still considering about some maintenance, because the gearbox, generator, gearbox, and some bearing, you still need to take time to maintain, okay, and shut down. So usually it's only just 10 to 30%, okay, 10 to 30%. So this is, I would say this is for a real situation, and this is for the best design, and this is just only for theory. So let's just take a very simple example, okay, to show you how to calculate, okay. So if you have that turbine, this is the perimeter, and you have the radius. This is the radius. So the sweep area A is the pi r squared. So for example, let's write here. Okay, this is based on the turbines parameter. Okay, and then you can get low average and not low power. Power available. Power available, that means based on this condition, how much power we can generate. The wind turbine can be generated. And then multiplied by Cp. So easy question. Very simple. You can get multiplied by 1.23 and 8 pi to a meter. This is A. And velocity This is a mega, okay. So the available is the available power is for the based on wind turbine. It produce 3.6 megawatt. 3.6. So for 40% conversion efficiency is quite high. Okay, it's quite high. So if you take into account for 10%, you have to divide it for so maybe only around 1 mega, yeah, less than 1 megawatt. Okay, 1 megawatt. All right. So this is an example that a wind turbine theoretically and an example to show you how to calculate. Of course, the design of the wind turbine has a diverse difference. I mean the shape, right? The shape. So it is still need to take some investigation or some research in order to get the high efficiency of the wind turbine. So still, I think a lot of the research group is engaged to develop a blender, okay, a high efficiency blender. So you have to consider about the air flow rate, mass flow rate, okay, mass flow rate, and to evaluate. So I think this kind of research is quite, it's not, I think should be quite well known because it is easily that we can use some simulation, okay, like some final element simulation. You can theoretically to calculate about the wind field, okay. You just need to understand about the wind field difference, and then you can foresee some difference parameter, and about the theoretically of the design for different kind of the blender. So you can get some study just using some simulation and computation to understand about the output power. Okay. So next, this is a different type of wind turbine. You can see there's a different type of wind turbine. So far, the most common is I think this type. You can calculate about the wind turbine. So we are ready to show you. Okay, so the wind turbine, mostly because the wind turbine is the technology is quite well known and well established. Okay, it is not difficult, but the problem is the loudly. It is quite loud, noisy, right? So it will be very hard to construct the wind turbine in the residential area, right? Like school, like some city, it is impossible. So only the way is to construct the wind turbine in the ocean area, coastside, right? Because that area has there's no issue about some of the people work around there. So this is the voice, okay? And you can see about the comparison, okay? For example, this is 50 dB for internal air conditioning, and for the vacuum cleaner, it can reach 80. It's quite loud, okay? Quite loud. And this is also one of the cases that it is easy to damage when there's a storm. So, based on the wind turbine, it is also quite expensive. Okay, quite expensive. So, how to having a wind turbine to construct an offshore wind turbine. Mostly right now, there's many countries they develop the wind turbine in the offshore country. Offshore, that means just in the ocean. Okay. So this kind of the case that the serious issue is because inside have some gearbox, right, and bearing, right, and there is a mechanical property issue, corrosion issue. Corrosion issue. So you need to do a lot of time to maintain, such as wind power and such as manpower. Okay, you have to take the maintenance. The maintenance is also a cost, one of the costs. And compared to the solar cell, okay, photovoltaic. Okay. Photovoltaic, I would say the maintenance time is more or less, right? You just need to consider about efficiency, right? Efficiency. And of course, you still have to consider about if there is a typhoon or power, then you could damage the solar cell as well. But I would say, because this is dynamic, the blender is dynamic for the wind power, is dynamic. And its size is large, right? The size is large. So therefore, for the stone, for the power for the stone, is quite easy to know. If the blender is large, this blender, when there's a power, wind power, a stone, it could have a strong bending, right? Do you understand? It's a strong bending. So once the blender has a moment, and then it is easy to damage. Okay, you can see. This is a blade, right? You have the force, the blade. On the angle of the blender, it could create a huge moment, right? A huge moment. So easy to damage. Okay. But compared to the solar cell is a panel, okay? It's a panel side. So there's no such issue. Okay, next is the geothermal energy. For the geothermal energy, it is compared to the wind power, solar power. Solar thermal energy, you don't need to consider about the area. But for the geothermal energy, you have to consider about geologically, right? Geologically, not anywhere, not every country has a geothermal energy, right? So it is quite limited. But anyway, let's understand about that. This is not difficult. Okay, you can do it by yourself. This is only the Earth's heat. Okay, Earth's heat, because of Earth's heat. Some of the hot spring. This is in the Nevada state. Okay, and there's a steam from the reservoir to power the turbine generator. Okay, so you can power the turbine and generate electricity. Okay. So there's two kinds of here. Is a schematic diagram. So you can see the underground here. There's hot water, and then you get the hot water to the box here, and then there's steam. Okay, to generate the steam and power the turbine, get electricity, and when condensed, the water being condensed become cooling water, and then reflects, inject to the oil. Okay. So there is a difference. Geothermal energy. One is the dry steam. Another one is I would say the fresh steam. And later on I will show you. Okay, later on I will show you. Let's see a video first. Okay.
Geothermal energy gives us a steady supply of electrical power with minimal environmental impact. Here is the basic process. Water in underground reservoirs is heated. Geothermal energy gives us a steady supply of electrical power with minimal environmental impact. Here is the basic process. Water in underground reservoirs is heated to high temperatures by magma.
Okay, this is the video.
As it travels, the pressure lessens, causing a small amount to become steam. Together, the hot fluid and steam move through us. Geothermal energy gives us a steady supply of electrical power with minimal environmental impact. Here is the basic process. Water in underground reservoirs is heated to high temperatures by magma. Production wells drilled up to 10,000 feet below the Earth's surface tap into this hot fluid. Under its own pressure, the fluid flows through these wells toward the surface. As it travels, the pressure lessens, causing a small amount to become steam. Together, the hot fluid and steam move through a surface pipeline to a wellhead separator, where the pressure is reduced. Here, most of the fluid vaporizes and flashes into high-pressure steam. Any fluid not flashed into steam moves to a standard pressure crystallizer to produce standard pressure steam. Remaining fluid is then flashed at a lower pressure to create low-pressure steam. All steam created in the plant is sent to a turbine on site. The force of the steam spins the turbine's blades, which turns a shaft connected to an electrical generator. An electrical charge is created and directed to a transformer, where the voltage is increased and sent down power lines. Any fluids not flashed into steam return to the underground reservoir, where, in time, they will be reheated and reused. Geothermal energy, a simple, clean, and renewable energy source.
Okay, here is video. Okay, this video shows you there's a high pressure steam and low pressure steam. Okay, so what is the high pressure steam? High pressure steam you also can call it dry steam. So this dry steam just produced in the well. Okay, because underground there's hot water. Okay, so you can produce the dry steam. So the dry steam just directly power the wind turbine. directly, okay? Directly powered with turbine. So you can say the dry steam plant, okay, use the steam naturally produced from the ground, okay? And then the steam comes from the production of the well, okay, to turn the generator turbine, okay? So this is the temperature variation, okay, the temperature. And next is the low pressure steam. We call it flash steam, okay? How the price, because the underground, there's a different pressure, okay? You have the high pressure, low pressure, and you also have the hot water, right? So if now, right here, if we can create a flash tank, this flash tank has a low pressure flash tank. You know, the low pressure flash tank, we can use the lower temperature to generate the steam, right? For the low pressure. Just you climb the mountain, right? To the mountain, in the mountainside, if you want to boring, to cooking the how to say that? The rice, right? Or the noodle, right? Because the temperature is quite low, and then you can get the boring, right? The vapor can be generated at a low pressure at the mountainside, right? So here, just similar situation, okay? For the flash tank, we can use the very low pressure flash tank. Then we can control this facility. So therefore, the low temperature for the hot water goes to here, and it can generate the vapor as well. Okay, so this vapor can power the turbine, okay, and power the turbine. So therefore, you can have the different temperature. You have low pressure, middle pressure, high pressure, and you can design different kind of flash tank, right? And you can get, because the only way we just need the vapor, right, from the water, right? We just only, because the vapor can have a kinetic energy, right? So making this kinetic energy to turn the turbine and then to generate electricity. So once the vapor, because the vapor can condense, become the water, and then it will be injection to the well, and then reuse again. So this is the geothermal energy, and here is the temperature. Okay, here is the temperature. The temperature usually is lower than this temperature. Okay, dry steam. Okay, here is a different steam power plant. Okay, it is quite simple. Next is biomass. Okay, biomass. For the biomass, especially in the recently, I would say recently 10 years, there's many research group and also some manufacturing company, they engage to do such biomass. This is because of, if you think about that, there's waste food, right? Because every day we have the waste food, right? And waste food that if we can reuse this waste food, and also some of the agricultural waste, right? Like rice straw, rice husk, right? Which is abandoned, right? And then every year, every day, that there's a many countries produce this waste agriculture. So if we can fully utilize this waste stuff, and which might be one of the solutions that we can produce the green energy, right? Green energy. Use some of the waste stuff. So this waste stuff, like cellulose, you know the cellulose, okay? Cellulose is just like a fiber, okay? You have the hemicellulose and also cellulose. Later I will discuss about that. And because of this cellulose, there's a major composition we call the glucose. Okay, glucose is one of the small sugar. Okay, this glucose you can treat the glucose by fermentation process. You know the fermentation process? Just like the brewing beer, right? Alcohol, brewing beer. And you can convert such sugars, such glucose into the alcohol. Okay? And burning the alcohol or burning the ethanol, which can significantly reduce the emission, especially in carbon dioxide. But you have to consider about the process, right? How the process we can produce, how many percent of the glucose, and how many percent of the energy we consume. Okay. Still, we have to calculate about that. So here is a biofuels, the description. I think that you guys can understand about that because this is additive. Okay, can typically reduce the vehicle emission typically at least 20%. And now, even more low because the technology has been improved. So therefore, some of the alcohol, some of the ethanol and oil can be even very clean. Okay, very clean. Still, people consider about P25, PM 2.5, once burning about the ethanol and also oil, you still have to consider about the air pollution issue. But based on this biofuels, actually right now, the emission has been reduced significantly, a lot. Okay, so what is the process? So the major composition right now, you can see, for example, this is from corn. Okay, from corn, like 玉米树 corn. Also, for example, rice. Okay, rice. And you can see this plant cell. Okay, there's a plant cell. Here is a microstructure. You can see layer mesh of the microfiber in the plant cell. Okay. As you can see right here, for a single microfiber, you can see there's a small fiber and huge fiber, right? For the inside blue color right here is the crystalline cells. And then surrounding on the blue crystalline cells, there is a hemicellulose. Hemicellulose is a, I would say, semicellulose. Semi is the same. But, okay, just have, that means the crystallinity of the hemicellulose is much lower. Okay? And then the mechanical property of the hemicellulose is much small. Why we need much small? Because if you want to brew beer, right, to generate the sugar, we need the hemicellulose. That means the small crystallinity, low crystallinity of the cellulose, because it's easy to dissociate. Understand what I mean? Easy to dissociate. If you have the huge crystallinity, you have very difficult to dissociate during fermentation process. Do you understand? Because the fermentation process, you need a temperature. You have to control the temperature, control the environment, right? And then you have to add some yeast. You know the yeast. Yeast. If you want to, your mother cooking the bread, right? The bread, you have to add the yeast. Otherwise, your bread will be very hot, right? 太硬了, so you need yeast. 酵母 is for manual. Yeast is like is alive, right? So during fermentation process, you need to add the yeast. So therefore, you can fermentation for bread, for ethanol, for something else. All right. So you have to pass through the fermentation process to make it the hemicellulose can be dissociated, and then fermentation process without oxygen, so we can produce the ethanol. Okay, so this is the cellulose. You have the glucose. Okay, so we need the major composition is we need the glucose. Okay, so here is the cellulose structure, and here is the microstructure. Is a chemical. It's a chemical structure of the hemicellulose. You can see this hemicellulose is much. I would say there's many OH. Okay, many OH bond, so which can react with the reactant. Okay, with the reactant. So small fiber will be good selection because here is a monomer and beta cellulose glucose. So this is the process. You can see, for example, sugar cane. Okay, sugar cane is like a sugar cane bagasse. Bagasse is the waste. Okay, sugar cane waste. So sugar cane waste you just need have to throw away, right? But sugar cane waste we can correct, and then to get the hemicellulose hydrolysis process. Okay, hydrolysis, you know, hydrolysis process, and then this process is to release, okay, xylose, okay, from the hemicellulose, okay, from the hemicellulose. Once we get the hemicellulose, and then there's a separation, okay, to separation. Separation what? To separate the sugar from solid. Sugar, that means the glucose, okay, from solid, because there's some crystalline cellulose, right? That means to get this hemicellulose and then throw away the crystalline cellulose, okay? Just separate. 分离的啊 ，okay， 分离。So you get the glucose, okay? Once you get the glucose, that's more easy. That you have to fermentation process and the yeast, okay? And then you can get fermentation brewing. You get the acid, okay? Here is the xylose fermentation process. So you can ferment it, okay? The acid, okay? Finally, you get 蒸馏, okay, distillation, okay, and then to recover the acid. And then this is the byproduct, okay, lignin. Okay. Lignin is one kind of, I would say, the waste, okay. This is hard to dissociate, okay, lignin. Lignin is the 木质素, okay. Hard to dissociate. Very hard to dissociate. So this is the waste. Okay, the waste. Okay. So the fermentation process is right here. Okay. So all this stuff you can see, like the waste of the livestock, okay, dung, okay, and also some food, waste food, and raw garbage. And here, all of the waste we can pass through the mixing fermentation process, and to get the biogas. And actually, this fermentation process, there's many types. Okay. One of the type is here. Okay, you still need to use some combustion process, which means you have to burn. Okay, to burn in order to get the temperature. Okay, to get the temperature. So once you burn in, you can produce the steam. Okay, and you also can power turbine as well. But unfortunately, once we conduct it, because this waste, although it's a waste, but you still need to burn. Once you burn it, and then you generate carbon dioxide emission as well. Okay. So this is still we have to consider about that. So the biomass energy rely on the combustion and then therefore produce the carbon dioxide. So it is used will not be therefore alleviate the greenhouse effect. So some of the research still have such concern. It's because of the once we pass through the combustion process, they still generate the carbon dioxide emission. And also is one of the consideration is because of the major raw materials is the plant, right? Plant. So you cut the plant to produce the biomass. But this plant can absorb the carbon dioxide, right? So therefore, you cut the plant, produce the gas. But this plant can absorb the CO2, right? So it is a trade-off, right? It is a trade-off. So still have to very detailed to understand about which one will be more eco-friendly for the environment, okay, for the environment. And also, byproduct, okay, there's also have some bio byproduct. You know, we have the textile, right, and plastic, right? This plastic is one of the byproduct from fossil fuels, right? From fossil fuels. For the biomass, you also can produce bio byproduct, okay? Bio byproduct, because there's many steps of the product being produced. So, for example, you can have the plastic. This plastic is a byproduct of the biomass. So this is very eco-friendly because produced from the bio, right? So that means once you throw away, it is easy to dissociate in the soil, right? Under the soil. So no worry about the traditional fossil fuels byproduct, right? Compared to the traditional fossil fuels. Traditional fossil fuels of byproducts such as plastic is hard to dissociate, right? There's many research scientists, they're concerned about the ocean, right? Some fish eat the plastic, and then the fish, you know, some like whale, 鲸鱼要怎么讲？ Whale, right? Whale, and also some fish they eat, and then some sea lion, right? Some anyway, some like they eat the plastic and then die, right? So this plastic of the waste in the ocean still one of the critical concern, okay, critical concern. But this green plant, okay, byproduct, yeah, is more eco-friendly, okay, and also artificial sweetener, okay, toothpaste is also. So here is a very trade-off, okay, food is important, and plant gas is also important, right? But some of the, you know, still we have a lot of people in the earth. They need the food, right? They need the food. So if we use the food, right? We use the fuels from the plants, which means the less area, the less area can be used to produce the food. So that means the people still suffer of the hungry, right? The hungry. So therefore, here is also one of the debate issue. Okay, one of the debate issue that we still need to take into consideration. That's why last week I have talked about that there's a very important course, which is the economic energy. Okay, economic energy. Economic energy is in detail to understand which one we have to evaluate, which one renewable energy will be best for the future. Okay. Let's take a 10-minute break.